Golang is one of the best programming languages to learn. In this video, I'll show you how I learned it, and this video will be towards anyone who wants to learn Golang. Now, whether you're a totally beginner in programming world or you have some experience with other programming languages, this video is for you. So let's start with what is Golang. So Golang is basically a general usage programming language, but it excels at server management. If done right, Golang with servers can excel servers written in Rust and written in C. And if I want to give you a little bit of history, so Golang is made by Google. And the main cause or the main reason that they made this language is to manage servers. So you can understand how powerful this language is in servers. And I personally use it in my own projects. And I came from Python back in the day, and I noticed about 10x improvements when I moved to Golang. Golang also handles concurrency with a very good model that is the Go routines. So with Go routines, you can spun up as much Go routines as you can to do things in a concurrent way. And this is perfect for servers because you want to handle requests in a concurrent way. You would probably want to do some jobs in the background while you actually responding to the request. So that's one of the core pros of Golang, but it also does all of that with garbage collection. And garbage collection meaning you don't have to have the headache of managing memory yourself, like C, like Rust, and other programming languages that offers performance, but comes with handling managing the memory yourself. With Golang, you don't have to manage the memory yourself. The garbage collector does that for you. And if you don't make garbage, then there is nothing to be collected. So in this video, I'll show you how I learned the language, and I'll take you step by step. I'll walk you through how to learn it. By the end of this video, you will be familiar with the basics of this language, and you will be ready to start following up tutorials, because the last thing you want to do is just learn the language for the sake of learning the language. You want to actually use the language in projects and build projects with the languages that you learn. So in this video, I'll show you the basics of Golang. You'll get all the basics and you'll be ready to dive in some projects. And also in my channel, you can find projects you can follow up with this language. So the way I learned this language, I just simply searched Golang and I went to the first link, and then in the official documentation, you will find something called the Go Tour. Go Tour is basically takes you through a tour to learn everything about the language. And in this video, we will do it together. Now you might ask yourself, well, why do we do it together? I can just do it myself. Yes, you can. But in this video, I'll take you step by step, and I also explain things from my perspective. I have used this language for over 2 years now, and I have, some experience with it. So if you want, somebody to take you, to be with you in this journey of learning Golang and not just be lonely and learning by yourself, then go ahead and watch this video until the end. You will be familiar with all the basics because we will go through the whole Go tour. So let's get started and let's see what is Golang and how the code looks. All right, so to get to the tour, we just go to the official link of the Go programming language. And then we go ahead and click the learn. And then you have to install obviously Go, and in macOS, you can just simply install it by running brew install. So I did it with brew. So let me just show you how I did it. So I just brew install Golang, and you can install it this way. Now you can also install it whatever documentation here. So follow the documentation and install the language, and let's get started. And you don't even have to install the language to get started with the tour. So as you can see here, we have selected tutorials, documentation, and then there is tour of Go, and there's examples if you want to follow up when you can finish the tour. But I recommend starting with the tour. Okay, so let's take a tour of this language. It opens up very good IDE where you have the documentation on the left and your code editor on the right, so you can write some code while you learn the language. So we can see here, hello, and I guess this is ni hao. Welcome to a tour of the Go programming language. This tour is divided into a list of modules that you can access by clicking a tour of Go on the top left of the page. Okay. You can also view the table contents at any time by clicking the menu on the top right of the page. So clicking the menu, you can see the context of this tour. Now we will go in this video through the basics, but you can, follow the whole tour by yourself if you want. All right. Throughout this tour, or throughout the tour, you will find a series of slides and exercises for you to complete. Okay, awesome. You can navigate through them using previous page up, page down to the next and the previous pages. So basically, I have done that probably like 3 years ago, but in this video, I'll do it with you live, almost live. But you know, I have never visited this page from the last time I did, which is about like 3 years ago or 2 years ago. Okay, so let's get started. The tour is interactive. We can click the run button to run the code, whatever. Okay, these example programs demonstrate different aspects of Go. The programs in the tour are meant to be starting point for your own experimentation. Okay, so basically they give you some snippets of code that you experiment with, and you can start learning the language this way or learning the syntax. So edit the program, run it again, whatever. When you click format, Control and Enter, the text editor is formatted using Go FMT tool, which is basically a formatter for the language. You can switch syntax highlighting on and off by clicking the syntax button. So basically, if you click the syntax button, you get some little bit of, you get some colors in your code. When you're ready to move on, click the right arrow. So you click probably the right arrow here. Okay, so let's start with the basic program of Go, which is a program that prints hello world. And in this case, hello ni hao. Now, basically, every code or every file in Golang will start with the package definition, because this language is made out of packages, right? So when you define any file, you would define it with package main. So let's just get started and do that. So for example, we can say package main. Now you can say any package, right? Any package name here, but the starting point of the Go program would be in the main package. And the main entry point would be the main funcs, right? So you would create a func called main. This is would be the main entry point for the program. So think about it as the way that the first thing that will run in your program. So your program will be executed from this function, and then the other functions you include in this function will run, okay? So main, and to define a function in Golang, it's just so simple. You just write func, right? 4 letters, and then you would write the name of the function. In this case, we would be writing main, but any name could do. So for example, say we have a function that says hello, right? Now let me make it a little bit big so you can actually see the code here. All right, so we can write, for example, the hello function, and the hello function is a simple function that will say hello. So as you can see here, I open up parentheses. Those are for implementing arguments here. So you can say, oh, I want to print hello to the name, right? So the variable name, and then the type of this variable would be string. Now, I said this is also for total beginners, so I have to explain sometimes, but I don't expect total beginners, but okay, we will explain the types. I'll try my best to explain everything. So a variable is basically a place to hold. Now I'm not gonna, actually, you know what? I'm not gonna explain the types and everything, because this is a Go programming language tutorial and not programming in general tutorial. So you should be familiar with variables, types, you know. But here we have a variable that is a name of type string, okay? And then we open up the curly brackets. Now you can also define the return type of the function by just simply, for example, typing the type of the return that will be returned from this function. Okay, so for example, we have a function that's called hello, and it has a name, and then it returns error, right? Basically, if there is any error. Now, printing doesn't usually have any error, so we're just gonna skip the error like that. Now I'm using some Vim control issues, that's why I'm pressing enter and exit and all of that. Okay, so in the hello function, we will just print hi to the name, right? And to do that, we will use FMT. Now, FMT is a package that is in the official packages of Go, and this package allows us to print stuff to the terminal, to the console, okay? So to import a package in Golang, you just write import statement, and you import right away the name of the package you want to import. In this case, it would be the FMT. Okay, so then we can use it with the same name, or you can have another name for the package. For example, you can say printer, all right, to name the package so you can use it, but you can use it right away like this. Okay, so we can say fmt.print, okay, and I believe it's print like this, and then you print the name. Now, if you want to print with a variable, you can use printf. All right, and printf allow you to use the formatting, like the string formatting, to include a variable inside your print statement. So we can say hi, and then we use, you know, percentage sign and then s, which indicates that we're going to use a string here. Okay, so after that we end the quotation marks, and then we add the name or the variable that we want to include in this print statement. That will be the name, right? So this way we have defined the hello function, and the hello function will just simply, you know, print us hi to the name that we will define to it. Now we will define the main function, which is the main entry point for our application, which will go something like this. So func main, and then we open up parentheses like that, and then, or curly parentheses or curly braces, whatever. Inside of this function, we can call other functions, or we can do the logic basically. So we can call this hello function, just let's say hello, and then we give it the name of the variable. So let's say hello go, right? Let's say hello go, and we're going to go ahead and run the executor, and we can see that it's waiting, and it says hi go. So the program is correct, and we printed hi go. We can also change this to be world, and we can run the program again, and this way we will print hi world. So this is a very basic Golang program, and it shows us how do we define functions and so on. So let's move out. So let's move up to the next page. And this page available in other languages. Let's continue. There's an offline optional, you know, you can do it after installing Golang. So you can also install the tool and do it. Okay, and then we have the Go playground. Let's just continue with this. Okay, cool. Let's go to the next lesson. Okay, so it says packages here. Every Go program is made up of packages. Programs start running in package main. So as I said, your Go program is made of packages, and the starting point of your Go program would be in the package main, specifically in the func main. All right. So this program is using packages with imports path, math, and rand. So as you can see here, we're using two packages. We use the FMT that we just used in the hello function, and we use another package that is math rand. By convention, the package name is the same as the last element of the import path. For instance, math rand package comprises files that begin with the statement package rand. Okay, so math rand would be files in the package rand. Okay, so we can say here print function or print line, my favorite number is, and you can run a number, a random number integer n, and then you give it the, I guess, the size of the integer that you want to run. So we can run this program, and we can say my favorite number is 1. We can run it again, and it should give us a different number between 0 and 10. All right, so next. So imports. This code groups the imports into parenthesized factored import statement. You can also write multiple import statements like this. So you can either do it in parentheses like this, which is the common way of doing it. I don't remember any other time that I imported a package this way, only if the package I import is just one package. But if we have multiple packages, which is obviously common in your programs, you would import it like this way, right? So that's fine. But it's a good style to use factored import statement, as they also recommend here. So basically, this is also another math, but here we just imported the math package, not the rand package, which is a sub package of the math package. And we have the number right here. Okay, so the other one is exported names. Exported names. Okay, cool. In Go, a name is exported if it begins with a capital letter. For example, pizza or pizza is an exported name, as is by, which is exported from the math package. Okay, so we have a variable called by, which is exported from the math package as a constant with the by value. Pizza and pie do not start with a capital letter, so they are not exported. Okay, when importing a package, you can refer only to its exported names. Any unexported names are not accessible from outside the package. Run the code, notice the error message, and fix it by this. Okay, so let me give you a quick overview of Go and how does it manage exporting variables. So in Go, when you write your files, you have a bunch of files, a bunch of packages, and you might want to export a variable or a constant or a function from this package to another package, to use it in another package. And we don't have an export statement or an export keyword to export a variable or a function, like for example in JavaScript. You just simply do it with the variable name. If the variable name starts with a capital letter, it would be exported to another language. So for example, if I want to define a variable here that I would use in other packages, I would say var, for example, the keyword to define a variable, and the name of the variable. So let's say boo. This boo, of course, we give it also the type, so a string. This boo variable would be available in other packages when you import it. So when you import the package name, if I define this boo in another package that called, for example, foo, you can import the package foo and you will get access to something called foo.boo because we exported this variable. However, if we did not export this variable by writing it with the lowercase letter, we would not be able to access it from another package. As you can see here in the math package, we have a variable called pi. Now it's not this small letter pi. You cannot access a small letter variable. So if we run this, we will get an error. As you can see, undefined math.py. But if we change this to the capital letter, because there is a variable with the capital letter P in the math package, we can simply run that and see that it prints us the exact value of the pi. Okay. Let's continue with functions, but I'm going to check the recording and come back. All right, so functions, a function can take 0 or more arguments. As I said, a function, you define it with the keyword func and the name of the function. And then in the parentheses, you can add variables or arguments to the function. And the arguments, you define them with the name of the argument and the type of the argument. In this case, we have x int and y int, so of type integer. And then you can define the return of the function, which will be here integer, right? The type of integer. You can also return a variable. So for example, we can say z here as type of int, and when we return, we should return z, right? We can do something like z would equal x plus y, and then we return z. So you can also do that, right? And it says here in this example, add takes 2 parameters of type int, and then notice the type comes after the variable name. Basically, when you define a type in Go, the type should be after the variable name. So when you define a variable here, for example, we can say boo. The type of boo should be here. You cannot write it like var string and then boo. You know, that would be wrong syntax. Okay. So this function would basically add 2 variables, and we add. Okay, let me actually make something here. Let's add. Okay, let's add 6 to 7 and just see how much the value would be. Okay, we have a syntax error, an expected name int after top level declaration. All right, so we have a problem with this function here that says unexpected, but I used to use it like this way, but maybe, oh, so it's probably thinking that we have int here, but we can say, hey, z of type int, just like that, maybe. Yes, so it's expected it's 2 variables, the other declaration, but now we fixed it by adding parentheses. So you can add named returns, okay? Named returns only work in parentheses. Yep. So this way we have the functions defined, okay? Let's go ahead and access the next thing. So functions continued. When 2 or more consecutive named function parameters share a type, you can omit the type from all but last, okay, but the last. Okay, so it makes sense if you have multiple variables that you want to define right away and write those types, you can write them or define them this way when you just define the name and then the type you omit it to the last, and it will understand that all of these are of this type, okay? So for example, you can add z here to use it in this function. So as you can see, instead of writing x int, y int, you can just write x, y, that is int, right? And you can use that. Obviously, we need to add another variable here because we added another argument, and we run this and we can see 65. Okay, cool. Continue. And then we have multiple returns. As I already mentioned there, if you want to add multiple returns, you either add them like this, right? Or you can add them named variables. As you can see here, we have a function that's called swap, and it will swap the strings and will return 2 strings. So for example, hello world would be world hello if we print that program, because it will just take 2. Actually, as you can see here, this is another thing in Golang, and I don't think I explained this. So in Golang, when you define a variable, if the variable is new, so if you didn't define it before, so it's not reassigning, you're just assigning the variable first time, you would use colon and then equal. This will assign the variable the first time. So you can do something like this: v equals, or in this case, it comes from the value of 0. So this tells Go basically to create a var that is v of type int, because it knows this type of this value, and then you would say v equals 0. So basically, instead of doing this, you can use this shorthand colon equal to initialize a variable. And to reassign a variable, you would go ahead and use the equal sign to reassign it. For example, v equals 1. And here, when we just print v, we will have 1 instead of 0. As you can see, hello world 1. But if we didn't reassign it, it would be 0. Just like that. Now this code is definitely same code as defining var as type of int, and then saying v, or v, and then saying v is 1. It would also print hello world or world hello 1. Okay. Named return values. Go return values may be named. If so, they are treated as variables defined at the top of the function. So if you have a named return, just like I did, you would treat it as it is an argument of the function, but it's not an argument, obviously, it is the return value. Okay, so for example, y or x here is a return value. So x will be the summation of this equation, and then y would be the return of this summation, and then returns nothing. So this it actually says returns nothing, but it would return those two variables right here. As you can see, these names should be used to document the meaning of the return values. A return statement without arguments returns the named return values. This is also known as naked return. So basically, naked return with named variables would return just basically the named variables. But you cannot do variables like this. So for example, if we say int and int, this won't work. Why? Because here you should return those ints, right? You should go x and y, and obviously you should define those as well. So this won't work, but this one would work. And if we print the split of the 17, it would split it just like it is defined here. Okay, cool. Let's continue. Now we go into variables. The var statement declares a list of variables as in a function argument list. The type is last. Okay, so var keyword will allow you to define a bunch of variables. In here, we define some variables like C, Python, Java, and all of them of type bool. Now we can define another type like v, x, y of type int, or int, and we can also use var, for example, name of type string. You get the idea, right? You get the idea. So here, a var statement can be at package or function level. We see both in this example. So as you can see, we either define our variables in the package level here, or we can define them inside the function. Now, keep in mind, you cannot initialize a variable outside the function. So for example, if I say var boo, right? Or not like this, but if I say boo, for example, I cannot use the shorthand here like this. If I say boo equals 0, and I want to, for example, print boo here, this won't work. And why it won't work? Because you cannot use the initialize like this in the package level. You can only use this kind of syntax inside the function. If you want to define a variable in the package level, you can either do var boo equals 0. I think this would work. Yes. Or you can also do var boo, it's int, boo equals 0. Right? Just like this. We can assign it in the package level. No, you cannot assign in the package level. You cannot assign. So that was the problem with this. You can either assign the variable at the time of initializing it, but you cannot assign it in the package level. Okay, so basically this is variables. Let's continue. So we have variables with initializers. A var declaration can include initializers, one per variable. So for example, var declaration, you can initialize as I did in the past snippet. Here we have I and j as 1 and 2. As you can see that we use the equal sign to initialize them. If initializer is present, the type can be omitted. The variable will the variable will take the type of the initializer. All right, so if, for example, you initialized right away, it already knows the type, so you can already, you don't have to write the type here. As you can see here, when we say var C Python Java, it is true, false, no. So this C would be Boolean, this Python would be Boolean because it knows that those values are Boolean, and Java would be a string value. When we run the program, we would see those right here. Now, short variable declaration inside a function. Just inside the function, as we saw that we cannot do it outside the function, the shorthand like this can be used in a place of var declaration with implicit type. So you can just define it like this way. It's a shorthand. It's commonly used in your Go programming, programs. You could just write the name of the variable and initialize it with colon equal and then the value. It will take the type of the value and it will initialize with the value itself. Outside a function, every statement begins with a keyword. All right, so that's the mistake that we did here. You cannot say this like that, right? But outside the function, you can only use keywords. Inside the function, you can use shorthands. You don't have to use keywords. You can reassign, you can assign, initialize without keywords. But inside the function, you should use keywords. Okay, all right. So the constructor is not available outside the function, and we can see all of this right here. Okay, let's go with basic types. So Golang have some basic types: Boolean, string, integers. As you can see, integers of different sizes as well. So here, integer is an open size integer 8 bytes or 16 bytes or 32 bytes or 64 bytes. And we have also n-side integer, which means this integer will take minus or positive or negative values, and signed will only take positive values. You can use this as counters. For example, if you have a count in your application, you don't want a negative value, so you can use this type in order to not use any negative value. So unint, int 8, int 16, 32, 64, and then int ptr, pointer, I guess. So to be honest with you, you don't really need most of these types. It's only when you create a very powerful, very, let's say, fine-tuned program, you can use those variables. But mainly you would only be using int, unint, those variables, or maybe 64, because some functions actually use that. Okay, a byte is basically, another way to say uint 8, so it's the same value. A rune is basically another way to say int 32, okay, which represents a Unicode code point. Okay, so this is a Unicode code point. You don't really have to focus on these, those are for fine tuning or whatever. We also have another type, which is float, right? And we have complex. I actually personally never used complex and never used rune, maybe because I mainly work with HTTP servers, so I never used most of these types. But I definitely used byte, and I definitely used ints and string and bool and float, but never rune or complex. Okay, this example shows variables of several types and shows a variable declaration may be factored into blocks, as in within import statement, whatever, blah blah blah. Basically, this is all the variables that you want to know and understand. Okay, let's go with the zero values. This is a very, very interesting and powerful concept in Go. Zero values. So when you declare a variable, let's say you declare variable bool of type like int, what would be the initial value before you initialize it with any other value? What would be the initial value of this variable? The initial value of this variable would be called the zero value. Right? And obviously with int, it's 0, with Boolean, it's false, and with string, it's an empty string, and you can see that right here. So the 0 value is basically 0 for numeric type. So any numeric type would be 0, false for the Boolean type, and empty for the empty string, right? So basically a string of nothing. Here we can see that we're defining a bunch of variables, but we never initialize them. So they will take the default value from Go to work with. So you can see here, fmt printf, we're printing the %v, which means a variable of any type. You can print a variable of any type, and we can use q here to print, I guess, the string. And we'll run it just like that, and we can see that it prints us the string. Now this Q prints the string with quotation marks. So if we change this to S, we will only see the string without the quotation marks. So we cannot see the string right away or exactly. So we add the Q to use quotation marks in the print statement, as you can see right here. Let's continue to the next lesson or the next chapter. So type conversions. Okay. So the expression type, right, T of V converts the value V of the type T, okay? So we have also a way to convert types in Golang. And to use that, you can use the T, which is the type, and then open up parentheses and use the value that will be converted to a type. Now, not every type could be converted, and we will check what does that mean in a second, okay? So for example, we have numeric conversions. You can convert a type of int, right? So like 42 to a float by using float 64 of type int, right? Or open parentheses, and then you put the int here and it will change the type of that variable. Also, you can change it to unsigned variable, unsigned integer, and so on. All right. Or simply you can, for example, define I equals 42 and then F equals the float of I, and then U will be the unsigned integer of F, basically. Now, unlike in C, in Go, assignments between items of different types requires an explicit conversion. Try removing the float or unsigned int conversions in the example and see what happens. All right, so as you can see here, so you cannot just, convert it right away. For example, var z unsigned int of F, you cannot do that right away like this, like in C, because this will give you an error in Go. You have to explicitly say, convert this to this type, okay? And you can remove this type because it will implicitly take that type because you used unsigned int of F. For example, if we run like this, it would be running just like that. Now we have a type interface. When declaring a variable without specifying an explicit type, either by using this syntax or this syntax, the variable's type is inferred from the value on the right-hand side. So for example, we know this. If you initialize v variable with the value of 42, it will just take the integer value of the integer type of this value, okay? When the right-hand side of the declaration is typed, the new variable is of that same type, okay? So for example, if you create a var I of type integer, and then you say j it's equals or initialized from I, basically j will take the same type of I, which would be integer. But when the right-hand side contains an untyped numeric constant, the new variable may be an int, maybe a float, maybe complex, depending on the precision of the constant, okay? So for example, if you have an I variable that is 42, and if you have f that is, this kind of number, g would be what would be a summation of this. So it already knows that this would be a complex number, this would be a float number, this would be an integer number. Okay, so for example, you can change this. It's basically saying that the type would be coming from the value itself. Go is smart enough to understand what type of integer you use. So for example, if we say 42.2, it will also give us the type, as you can see here, because we use %t to get the type of this variable. So v here is float 64. If we just leave it as 42, it would be integer. And if we say v is hello, which would be string, it would just say a string, right? It basically takes the type from the value. Cool. Constants. Constants are declared like variables, but with the keyword const. Constants can be a character, string, boolean, numeric value. Constants cannot be declared using the syntax, initializing syntax. So a constant is basically a constant value, basically. So here, constants, you can define them via the equal sign and the keyword const. So you can say const pi equals 3.14, right? And this would be a constant value throughout your program, so you cannot reinitialize it or reassign it. So for example, here constant world would be ni hao, or world, I don't know what is this. I think this is not ni hao. I was saying ni hao. It doesn't matter, bro. Like if you from that side of the world, don't take offense. I didn't know. Okay, so basically this probably means world in Chinese, and maybe it's not even Chinese. Dude, don't take offense. It's my bad. All right, so let's continue. FMT print line hello, and then you use the world. The world basically is a constant of this, right? And you can do that with happy pie day or whatever, and then truth is true, just like that, and boom, you have those printed here. Okay, cool. Next would be numeric constants. And numeric constants are high precision values. An untyped constant take the type needed by its constant or by its context. Try printing neat int big 2. What does that mean? And an int can also store a maximum of 64-bit integer and sometimes less. Okay. So here we're defining a const that is big, all right? And we shift the value here. We shift 100. So create a huge number by shifting 1 bit left 100 places. I, to be honest with you, never used shifting in my programming because I usually just work with HTTP servers and handling requests and all of that. So those, kind of in-depth things, I never use them. And I wouldn't want to dive into them because I have no idea about them, but we can just, you can just read about them if you want, or if you have interest in shifting bytes or shifting variables. Okay, so I'm just going to skip through this one. And now, boom, you have finished the first lesson. You can go back to the list of models to find out what to learn next, or continue with the next lesson. So for example, with models, you can see we did only the basics here. We learned all the basics. Now in the next video, or maybe in this video, just let me take a little bit of rest. We can go ahead and do the methods and interfaces, and we can go ahead and do generics, or we can do concurrency. Now I'm going to leave it at this, and in another video we would go ahead and be interested or go through the methods and interfaces, and then go through generics, and then go through concurrency. So basically the whole tutorial. Okay, so that was it for today. If you liked this video, you know what to do. Consider liking it and subscribe to this channel for more Golang, automation, AI tutorials. This was More Than Coder. Goodbye. Also check out, this video. I think you will like it. Check out this video, maybe here. Check out this video, and yeah, enjoy.